All right, everybody. Monday, April 27th. We're going to start off with this on the pace. Go to this Desmos link and open this up. And make sure to use Google to sign in. I'm going to use the teacher one. And let's see who is in. Whoa, hold up. What is going on here? 1 second here. One second. Braden's yours opened up?
Yep.
Okay. Mine opened up to the wrong one. Let me fix that. Refresh. So I want to see who's listening to the recordings and who's not. So that's why I didn't put any instructions on number one. And as you can see, I have to sign in. Hold up. I gotta sign in with my Google, just like you guys. Okay. All right. So the first one, while you guys are there, can you write a function that is multiplying by 3 over and over? Go for it.
Should we give it a name?
Yes, you should give it a name. Most functions are called f of x. You can call it, let's call it f of x. This way we can all be on the same thing. So I got Olivia, Braden, Ethan. So 3 of us today. That is going to be weird. It's the lowest number ever. Okay. Tyler, are you in? You should be in there. Okay, so I want the function to be named f, and it should.
It won't let me.
Yeah, you gotta type in Google. Sign in with Google. So I should see your name up here, right? All right, so I want a function that is tripling, starting at tripling 2. So it starts at 2, and then it triples and becomes.
It's Toby.
There's Toby. All right, so it starts at 2, then it triples, then it triples, then it triples. Let's see, Ethan. I don't think this is tripling because if you look at the table, right? 0 times 3 is not 1. So I want your y-intercept to be 2. Then I want it to triple and triple and triple. So let's see what you guys can come up with. Braden, you're logging in again?
No, I'm still there.
Oh, there you are. Yeah. All right. And let's
Remember
see.
what we did last week?
Yes. Yeah. Look at your notes from last week. Yeah, Olivia. This is not tripling. It is. No, 2 to the 3rd power is 2 times 2 times 2. That's not tripling. It's basically 2 times 3, and then times 3, and times 3, and times 3. So that's not. All right. Looks like Ethan has it. If you're gonna try it by yourself, if not, you can look at my screen, and Ethan does have that function. All right, Ethan. One more thing. Underneath there, can you write an equation for the horizontal asymptote? So, what number is your graph trying to reach as it gets like? What number will it never touch?
0.
0. So underneath, write an equation. Either you're going to write x equals 0 or y equals 0, one or the other, and make that yellow and dashed. Yellow and dashed. All right, Braden's got it. Let me look at Olivia's. Good job. Okay.
Orange.
Orange is good too. Yeah, something like not the color. Yeah. So you hold down the that. Yeah, orange is good, and then make it like dash like that. All right. So I would like the function to actually, I want this function to move up 4 units. Uh, so let me hold on. Let me rephrase that. I want a new function underneath in blue, and let's call it G or B. B for blue. And I want it to be the same thing as this red one, but I want it 4 units higher than F. So I want it 4 units higher than F, and make it make it blue. But don't change leave your Brady, leave your F there.
Yeah, of course.
Yeah.
But do a second one as F of B.
You can do it G of X, right? I mean B of X, right? B, right?
B of X.
Yeah. B of X. And I want it to be in blue, and I want it to be 4 units higher. So basically a vertical translation, right? So look at your notes. How do we make a new function that moves up? Okay, so I want it to be okay. All right, yeah, that's fine. You can call it G, B. It doesn't really matter. So I want it to be the same as F, but I want it to be 4 units higher. I want it to be up, just like imagine you're just pushing that red line curve and just pushing it up 4 units. Let's see. All right, let's see.
Up 4 units.
Up 4 units. Okay, interesting. Let's see. Ethan, I'm looking at yours, and it looks like the y-intercept did go up 4 units, right?
Mm-hmm.
Underneath, can you type x equals -1? And are these 4 units different? These two here is 4 units from 0.667. No. So this is close. Your equation is close, but it's not, right? They have to be 4. The spread, the y-intercept did actually go up 4 units, right? All right. Anybody have an idea? Let me check out Braden's. All right, Braden, go ahead and click on where they intersect. Are these 4 units different? Like where your x.
Where they intersect.
Yeah, right. Are they 4 units off?
Yeah.
Yep. Can you put x equals I don't know, a different number, like what number you want, like -5? Are these 4 units different?
Yeah.
They are, right? So on the vertical, everything's 4. Even like if you put x equals 1, like +1. Make sense?
Yes.
All right, so let me check everybody's. If you're stuck, look at Braden's. Oh, Braden, you actually used you used an idea. Say, well, if you want it to be the same as F, well, let's just call it F, and then add 4, right? You can also, Braden, for practice, erase f of x and then type what f of x is, which is 2 times 3 to the x, right? Yes. Yours is better, but I want you to know that both ways work, okay? All right, now I see Ethan's got it, good. All right, let me see who else is here. Olivia's got it, good. Good job. All right, guys, I want a new function, and let's make it in a color purple, and I want it to be called p of x, and I want it to be the same as f, but to the right 5 units. to the right 5 units, which means the x's are 5 units. So are they going to get a head start or a delay if they're to the right? Hey, Abby, we're in.
What should we call this new one?
Let's call it P for purple. So I want it to be 4 units to the right, which means the y's will be the same, but the x's will be, I'm sorry, I said 5 units to the right, right? So 5 units to the right. So Abby, we started with a function. Here we go. Yep, 2 to the, yep, 3. And then don't forget the x power, right? And our,
5 units, you said?
Yeah, 5 units to the right of f, right? Very good. And how can you prove this answer is correct? Would you do a vertical test or would you do a horizontal line? What do you think? All right. So instead of, you know how we did a line, an intersecting line? That intersecting line, Brayden, can you make that in black? The x equals whatever? Yeah, make that. So you got to switch that to y equals any number you want. So like y equals 2, right? Y equals 2. And then go ahead and click on the intersection points of your function and the one. And is your purple line 5 units to the right?
Yes.
Yes. Any place you check, right? You can check change the y to 0.1 if you want, like something weird, right? 0.1. And then click on the intersection points. And that is exact. Yep, that is 5 units to the right. It's kind of hard to, but if you were to add those two numbers, yeah, that will add up to 5 the distance. Okay, you guys ready for the hard one? All right, let me make sure everybody's on the right track here. We got Olivia. Good job, Olivia. Got the 5 units to the right. Called it purple. And then the one that you test is in black. Perfect. Ethan's got it. And Abby is, I think she's almost got, yep, she got the 5 units. All right, guys. So the last one, I want it to be called M for Miguel, my first name. And I want 3 units to the right and 4 units down from F. 3 to the right, 4 down.
What color?
Let's see what color we have. We haven't used. Let's go green. And let's call it Miguel M of X. I want 4 to the right. I forgot what I said. 3 to the right?
I think so.
Yeah, 3 to the right, 4 down. 3 to the right, 4 down. I want a green. All right, Abby's got the right part. Yeah, you gotta do like one at a time, right? And then the down part. Okay, let's see. And I want it down. Want it down. There you go, Abby.
I got it.
Yeah, thank you. Good job. Okay.
Yeah.
Yep.
See,
there we go. Okay, and change that to green. All right. Now, this assignment will be really hard to do, actually be impossible to do without you listening to my instructions, correct? So when I see that people's assignments, I will know if they were listening to the class recording or not. All right, good job. Abby?
I didn't get all. I only have 3 of them. I don't have all of them.
Yeah, the first one. Do you remember what it was?
Can you just
yeah.
show me if someone else is, and I can just take a picture of it.
Yeah, let's
put it in.
Yeah, just the equation here. I think Ethan had the first one.
I think Brayden has it all.
Yeah.
Or maybe I don't know.
The first one was up, wasn't it? Oh yeah. Let's see. Brayden.
Well, the original one is is F.
Yeah, there we go. Yeah.
Should be the last one, right? Or
yeah, I think the first one we did was the red was the first, and then we did the blue. The blue was up 4. The purple was right 5, and the green was right 3, down 5, right? Okay.
Yeah.
So
So
can you guys click on one of these, and you're going to press the plus and then press note. And you're going to put up 4 units. And you're going to write the Y's change only. Of what?
Mhm.
Does that make sense?
4 units.
Yeah, not unis, right?
So
So
Y's change.
only the Y's change, correct? The X's stayed exactly the same. What are you going to put for the purple one? What are you guys going to put for the purple one? What did the purple do? Is the purple up, left, right?
It's to the right 5.
The purple one, I think I said right.
It's right 5.
Right 5.
Yeah,
Yep.
that's what I said.
Oh, got you. And what changes, the X's or the Y's?
The X's.
Yep. X's get a delay of what? 5. So it means minus 5, right? So they add 5. They add 5. Now these are opposites, right? It says minus 5, and then down here it says add 5. They look like they're opposites, right? But they're different. Okay, so these are like opposites. All right, last one, the green one. What are you gonna write on that one?
4 units the Y's.
Yep. So that was two things change, right? 2 things change. So then we're gonna do a plus note. And what are we gonna write on this one, Abby?
I was just reading what you
okay.
had already wrote. Yeah. Sorry, that wasn't me answering it.
Got it. What are we gonna write for the green one? Brady, what are we gonna write for the green one? What are we gonna write for the green one?
I wrote down it moves to the right 3, moves down 5.
5.
Yeah, right.
And what changes?
And the X's change by 3, and the Y's change by 5.
So X's, are the X's gonna go down by 3 or up by 3?
I'm down by 3.
It says minus 3, but it goes to the right. So
up by 3.
Up. So you're gonna say add 3, right? And then Y's subtract what? 5.
Subtract.
Okay. All right. Anybody have any questions so far? We're almost done with this screen. This is a good one. This is a really good. By the way, this is going to help you in IM2 and IM3 and pre-cal.
Wait, we're doing all 27.
Now, yeah, we might just do like 3 of them.
27. Oh, there's more.
Well, I just used one. Yeah. I mean, I basically made a blank one, right? All right, guys. Let's do one more thing. Underneath the F, can you put plus and then put expression? And let's see, Ethan, can you give me a coordinate on F?
Let me see.
Any coordinate that's anyone that's kind of easy. You got to give me the X and the Y. So you can pretty much put any number inside of X, and then we can calculate the Y. We'll know what the Y is.
1,6.
Okay, 1,6. All right, and that is on there, right?
Yeah.
Okay, 1,6. And then let's pretend that 1,6 was f of x's like mosquito bite. All right.
Makoto bite?
Yeah, mosquito bite. Mosquito. All right. So where is b of x's mosquito bite? Press plus and expression. where exactly is the blues mosquito bite? What coordinate? Now look at what you wrote underneath. What did you write underneath, Braden, for B?
4 units. The Y's change up 4.
Cool. So what is the mosquito bite on F at 6? Where is it going to be on the B of X?
It's gonna be 110.
110. Boom. And look, you can see that it is in the right spot, right? If you had typed in like 1-6, it wouldn't look correct. Like the spot wouldn't be at the right spot. Good. Okay. All right, next. Let me pick on a couple more people. Go to the purple, the P of X. And where is the purple's mosquito bite? Remember, they're all the same. They just moved, right? Let's see. Ethan or Abby, where is P of X's mosquito bite?
It could be 6.
6, okay. It says here X's get a delay of 5 at 5. So let's put 6, 6. It means the Y didn't change, correct? Let's see if 6 is on there. I gotta close my parentheses. Oh, I think I pressed the wrong thing. I pressed a note. Did it show up on there? 6.
You can move the thingy.
Okay, yeah. Let's see. Yep, it is on there, right? It's exactly on the right spot, right? All right, last one. Where's the mosquito bite on M?
The X is up 3 and the Y is -5.
Okay, so what is the original mosquito bite? I think Ethan said he picked 1-6. 1-6, right? So we're gonna add 3 to 1 and make it what? 4, right? Or you can even just put 1 plus 3, right? Comma, and then what are we gonna do to the Y's? There we go. All right. So what I just showed you right here is a way to find corresponding points, right? So on a future quiz, I'm going to give you some information, and you're going to have to tell me where is the corresponding point, okay? Anybody have any questions?
That point isn't... 1 plus 3, 6 minus 5?
Well, the decimals adds it up.
I know, but I'm saying it's not on the line.
It's on my green one. Let me see.
It's not on my green one.
Yeah. Oh, I have an idea. Check out your equation for the green. You might have put 4 because that's what I did say to do. What did you write for?
You're right.
Yeah,
I did 4.
And no, I did actually say 4, but Braden put 5 and I just went with it. But Abby, that is a way to know that wait, something's not right. It's not on the actual equation, right? All right. So, what kind of functions do you think you guys will get? The very simple one or like the green one?
Green.
The green. But the green comes from the very simple one. Make sense? Okay. So, let's go to screen number 2. Okay. And this time, and you guys could talk to each other and everything, write me an equation of me starting out with 1 penny and then doubling it every day. 1 penny doubling every day. Write the equation for that. And you can call it M of X, M for money.
Say it again.
You're going to start off with a penny, and then we're going to double it every day, and you're going to write the equation for that. Last time we started with $3.
So 1, and you're going to double it every day?
Yeah, every X, yeah. And then we'll call the X's days, right?
So Every X is a day.
It's a day. Yep. And you could actually click on the little gear box on the little wrench, and you could change the X's to days like this. And then you put money or dollars.
You start with 1.
You start with a penny, like so 0.01. Right?
Oh, 0.01.
Yeah, that's a penny. Well, I mean, yeah, because you don't want to. Eventually, it's going to turn into dollars, and you don't want to, be counting pennies if you have dollars, right?
So you start
I
at.
think I did this right, but I'm not sure.
Let's see. Start with a penny. Yeah, that was pretty good. Now go ahead and click on the little wrench that says Graph Settings, and change this where it says X-axis. Type is it label? Put days, and then the Y-axis put hashtag dollars or whatever you call them. Right? What happened? Here we go. And then so you put $, right? Now, when will you have $1 million?
$1 million?
Yeah.
Well, I can just find that point.
Yeah. You could also put Y equals $1 million.
Y equals 1, 2, 3.
And then now zoom out. You can find the intersection, right? Whoa.
Wait, hold on. Abby, you put 0.1 instead of.
Oh, that's 10 cents. Yeah. So good catch. So put 0.01. Good catch. That was 10 cents.
0.01.
Mm-hmm. Let me get out.
Let's see.
All right. Good job. And Olivia, go ahead and put a penny too. We got 10 cents on that one. Oh, and this one, you don't want to put plus 2x. It's actually times. Let me make sure that everybody has that.
You need to.
Yeah.
So what was your question about $1 million?
So before we do that, Abby, instead of the plus, it has to be times on the equation.
Well, you said it was right.
Yeah.
So.
Yeah. Now I figured out when I was trying to find $1 million, I couldn't find it. So it's actually times because you're multiplying by 2. You're not adding 2 or multiplying, right? So everybody put in times, right? There we go.
It looks the same.
So now it looks the same, but it is different for sure. All right. So when does it reach $1 million? What day? So click on the intersection, and the X will tell you how many days it'll reach $1 million.
At 0?
No, at the intersection. Well, look at my screen where it intersects at $1 million. I'm looking at your screen. So, Yep. So you find out
I went over a little bit too far.
Did I pass $1 million?
Right here at 26 and a half days. That's what it's going to reach $1 million. Okay.
Yeah, I mean, if you want to give me a penny, you just want to do this for me, like give me a penny.
I'm telling you, right?
I don't know.
Watch this. Click on the thing, and then press the gear, and then put table. And then this one, you can actually type 3, 4, 5, 6, 7, 8, 9, 10, 11. We say, is that 20 something, right? 20.
26.
25. Yeah, 26 is more than $1 million.
It's
27. There we go. So at 26 is 671,000, and then at 27 is 1.3 million, right? Now I would totally give you $1 million if I was Jeff Bezos, right? What's his name? $1 million to him is probably like a penny to me. So let's see, he's worth 100 billion. 100. Anyway, whatever. So, all right. The last thing I want you to do on this screen is nothing. Let's go to screen 3. And let's go back to functions. So make me a function that starts at 4, doubles, but doesn't actually cross 1. This is going to be hard. And let's do this. Put it in parentheses. Put 0, 4. And then you're going to put y equals 1. So your equation has to hit 1, and it has to hit 1, 16, because we're multiplying. Oh, let's just double it, so it's not too bad. Okay, but it can't cross my asymptote. It can't cross this red line. This is harder. So the asymptote is y equals 1. So put these three points.
So can it touch?
It can't touch it.
It just can't go under.
It can't. Yeah, it can't. So we doubled 4 and became 8, right? So this is hard. Let's see what you guys can. Let's see where you guys are at. All right. So it's got to hit.
Dang it.
Yeah. It's gonna see it cross there, right?
How do I don't know how to.
Yeah. All right. Leave it just like that, Abby. Okay, because I did this on purpose for you guys. Okay. All right, guys. By the way, take a look at my screen. We won't be able to do it with our knowledge, but let me help you out. How far is 8? Oh, yeah, actually, Abby, you got to put 1, 8. But
okay.
It's yeah. All right. Ready. How far? The normal point would be 1. You're always starting at 1, right? So go ahead and put 0, 1. How far is this y-intercept from this y-intercept? 3, right? So let's bring this red graph. Let's bring it up 3. Wait, hold on. Let me remember how to do this. Let's bring this. Hold on. Let me remember. We're bringing it. They're 3 off, but this hitting the wrong spot, right? So we need to basically raise.
And then move it over.
Yeah.
Right.
Let's see. Yeah. Okay. Let's write 2 of x.
Oh, I'm so close.
Let's see. 2 of x.
Very close.
Yeah. And then plus 3. See that? Oh, what was the plus 1? There we go. So put 2 to the x plus 1. See, my blue line doesn't actually hit my asymptote anymore, right?
Yeah, but it doesn't hit your 8.
Exactly.
Your
right.
1 point. Does
it
have to?
It does. And I'll show you how in a second. First, I'm going to get rid of some of the mess here.
If you look at mine,
yeah,
I guess you're on mine, but you can't see what I added.
All right. You see this green one I have here? Here, let me go to your newest one, Abby. Okay. So,
I'm really close.
Yeah. So now you're hitting, but your red line is it has to try to reach the blue. So change that 3 to 1. Okay.
Oh, it has to hit that line? Oh, okay.
Yeah, it has to hit that. And then it has to hit 0, 4, right?
So that means I need to move it over to the left 1.
Let's see. Well, 1. Okay. All right.
No, so close.
All right. Let me show you guys how to do it in math. All right. Look at my screen only. I just got to find my stylus. Oh, it's in my ear. All right. Watch this. Okay. Everybody looking? So I said it has to hit 0. What was it? 4? 4? And then I
0,
have to hit
4, 1, 8.
and then 1, 8. And it can't cross y equals 1. Right?
But I have to touch y equals 1.
Yeah, well, it's sort of like it almost.
You said it had to.
Well, like it never really touches it, but it gets so close that it's touching you, right?
Oh.
It's sort of like if you put your fingers together, they're not really touching. There's always like a little bit of space in between. So it has to look like this. So and then here is y equals 0. So what we got to do is we have to pretend that is y equals 0. So that means we have to move it down by 1. So this is not really 4, it's really 3. And this is not really 8, it's really what? 7. Does that make sense? So we have to pretend that it's not 1, it's what? 0. So the 4 became a 3, and the 7 became an 8. The 8 became a 7. So is it doubling or is it not doubling? How do you go from 3 to 7? By multiplying. So 3 times what is 7? So how do you get rid of a multiplication problem? How do you guys undo multiplication?
Division.
Division. So you divide it by 3. So the rate is not 2. It's actually what? What's the rate? 7/3. How much is 7/3 in decimal?
Oh, I don't know.
It's actually 2.333. Okay. All right. Now watch my screen. Watch. I'm going to erase. So it's the rate is not 2. It's 2.333, and the starting number was what was the starting number? 3. Watch. And then it's plus 1. 3.
But I have the x minus 2.
Oh, got it. We don't need. Thank you. I did not catch that. Wait, how come it's not working? Now look at my screen. Whoops, hang on. So does it hit 0, 4?
Mm-hmm.
Yes. Does it hit 1, 8? Yes.
Mm-hmm.
Does it not hit y equals 1? Yep. Like Abby, it touches it, but it doesn't really touch it, right? It almost touches it. So I tricked you guys. The rate was not double. The rate was actually what?
How are we supposed to know that when you told us the rate was 2?
I messed up. Yeah. So let's try one more and then see if you guys can find the rate. So now I can't tell you the rate, right? Because the rate you don't know, you're gonna have to figure it out. Okay.
Wait. So how do we figure out the rate?
So the way I figured out the rate was I divided the second number divided by the first number. Right. But first, I reduced the 8, and it used to be an 8. I reduced it because I wanted to bring this graph down, right? Does that make sense?
Why did you want to bring it down?
Because all of the exponentials, they all want to hit 0, right? So this is my basic graph, right? So this one's hitting at 1. So I want to squash it down. And so that means all of the numbers have to change too, right? If I bring the graph down, the 8 becomes a 7 and the 4 became what? A 3.
Do you always bring it down?
Yeah, we always bring it down. You always want to bring it to 0, right? Because that's how you're going to find the rate. The rate, you're going to find it when it's all the way to 0. That's how you're going to find the rate.
Oh.
Does that make sense? So you can't find the rate when the graph is being moved up or down. you need to, you can only find the rate when it's hitting at 0. And then after you find the rate, well, then you can bring it back up, right? All right, we'll try another one together, all right? So this time, I want this graph, and then you guys can just to almost hit 2, right? I want it to hit at 5, and then the next one I want it to be at 10, right? So that's going to be
110?
Yeah. So it's going to be 1 comma 10, right? 1 comma 10. So I want the graph to look like this. I want it to almost hit y equals 2. It's going to hit 5. It's going to hit 10, and then it's going to go straight up. Now, you're going to think the rate is double, but it's not double, right? So you're going to have to bring all of the graph down. How much are you going to drop it down by? How much are you going to drop it down by? Because the y equals, no.
The y equals, what is it equal?
2.
Oh, 2.
So you're going to bring it down 2. So let me look at your guys' graphs and see if I can. Now,
and then
let's see.
you take the and what do you do for the first number, like in your function?
So what you want to do is you want to bring the 5 and drop it by 2. So what's it going to be? What is
3.
it? 3. So it's really 3, right? That's really your starting number.
Mm-hmm.
That's your
So
starting.
I put 3 right here.
Yeah, that's your first number. Now you need the rate. And what's the rate? Now bring the 10, bring it down by 2, which becomes what? 8
divided by 3.
So that's you can just put that 8 divided by 3. That's the rate. And then to the x power, right? And now bring your equation up 2, because that's what it says to do here, right? So what are you gonna do?
If I want to bring it up 2, then I add 2.
Then you add 2. And then I'll check to see if it hits.
Oh, it didn't work.
Let me look at.
It didn't hit 0.5.
0.5. Oh, I think the 3 has to be a 5 then. I might have made a mistake. Change that 3 to a 5. Wait, no. I see it. So Abby, the x power, put 8 over 3 in parentheses and then to the x power.
Oh, okay.
Because right now it's only doing the 8 to the.
Okay.
Right. So it'll look kind of like.
No.
Like this.
There we go.
Yeah, you got it. Let me see Olivia's real quick. Let's see. Olivia. You want to do the rate, Olivia? It's 8 divided by 3. So you could put if you change it to a decimal, that'll be 2.6666. So you could change the rate to that, and then you're gonna put plus 2 at the end, and it will hit 0.5 and 110, and not hit. Okay. All right. Let's see if everybody has that done. Let's see. Fixing that. Braden is working on it. Yeah. Yeah. Just get rid of that little exponent empty spot, or change the to a decimal, 2.6666. And then put the plus 2. All right. Good job, Olivia. Abby. Good. And then Abby, on the asymptote, the blue line, make it in dashed, like little dots. Okay. Do you know when you're going to be tested on this problem?
I am 2.
I am 3.
So why are you teaching it?
I want you to see where we're going with this, right? Does that make sense? So I want you to see that you're learning exponentials, right? You're learning the rates, you learn the asymptote. But when you get to IM3, it's the same thing. It's just that you're going to just shift it down or shift it up, and then so, I mean, so it's all about the shift, right? So remember, the hard part is it's just understanding that the asymptote is zero for all of exponentials, unless they got raised, right? And if they got raised, well, then you drop them back down, or if they got lowered, well, you bring them back up. Does that make sense, everybody? And then that's how you're going to find the rate. Okay. All right. And so that's going to be it for today, guys. And then tomorrow we're going to do some of the other slides. So just take a look at the other slides just so you can see, just for fun. So your job is you're going to press launch, and your job is to try to hit all of the stars. And you're going to have to change the equations, right? Obviously, that one's already fixed, right? So can we all look at screen 5? Okay, everybody go to screen 5. So if you press launch, the balls are just going to go right down to wherever they go, right? So we need to move this blue graph to the right. How much do we have to move it to the right? About how much do you think? Up? Are we going to put up, down, left, or right? What do you guys think?
15.
There we go.
15.
What you do is, if you, I guess it doesn't tell you the actual coordinate, huh? Yeah. Well, yeah. So it's at 15, but if
13.
13. Okay.
X minus 13.
X minus, because you moved it to the right, right? And then you press. Yeah, and the way you would do it is you wouldn't put the 13. You just say, "Oh."
I didn't get all the stars though.
What did you miss? Maybe. Oh, so it's got to go more than 13.
Oh,
maybe
so
like
it actually is 15. No.
Maybe even more.
17.
Yeah, let's see. Yeah, let me try 19.
18. Let's try 18.
Oh man, this is a slow. Look at this. How slow.
It's so lame.
It is pretty. It's like a little, snail. Now, I wonder if this one would work. Check this out. I don't know. Do you think it'll work?
No, it won't work.
No. How about if I put it upside down, like a little roller coaster? Let's see what's going to happen. Oh, they're just gonna stay at the bottom. All right. What about this one? All right. I wonder if it'll work there. I wonder if it'll work while my graph's moving. What would it do if the graph's moving? I wonder. Oh, it doesn't like that. See that?
Maybe you should give it a chance to land on the graph, then move it.
Yeah, maybe. Oh, that's right. Like after. Let's see.
Because you're moving the graph while they're falling.
Yeah. Let's see.
Let it land on the graph and then move it.
Let's see. Right. Yeah, you're right. Let me see.
The answer is the equation, but it's 19.
Oh, it's 19? All right. Thanks. All right. Anyway, so that's what we're going to do tomorrow. All right. So it's going to be a lot of guessing on that. How many screens are this thing?
27.
Okay. So today, for today's assignment, I'm only going to grade up to 3, right? But I'm going to make it worth 20 points. So you guys all get 20 points because you were with me. But then basically, you know how I give you guys grades? I just go to my summary and then I see that you did it. See that? So Tyler, he wasn't able to get in. So I could tell, right? And I guess a check mark means you got it right. I'm not sure.
Because if you fix it, you can get it right.
Okay.
Because you have to get all the stars.
Exactly. So, but for the rest of the class, they're going to have to log in. They're going to have to listen to the video. So good job on you guys for doing that. And I hope you learned something today. I got to go take some allergy pills because my nose is all stuffy.
Same.
All right, guys. Have a good rest of your day. See you tomorrow. I gotta lock this up.